In this video, we're going to look at two separate topics, composite functions and replacement sets. A replacement set is a set of ordered pairs that we match up with a function and we see which ordered pairs work for that function. In other words, if this first point were to work for the function, when I substitute -6 in for x, I should get 13 for f of -6. Any point that works for the function belongs to the solution set. So we're finding points that are solutions for that function. So the way this works, we just take our first x coordinate. So here we have -6, so I would say f of -6, we substitute it in, and when we do this we're going to get -18 minus 5, which is -23. Well, we were supposed to get 13, so -23 does not equal 13, so this point is out. Then we move on to the next point. We want to find f of -4, and if this point belongs to my solution set, we'll get an answer of -7. So we have -3 times -4 minus 5, which is 12, minus 5, and we get +7, which does not equal -7. So this value does not belong in my solution set. Then we move on to our next point. Our next x coordinate is 0, and if it belongs to our solution set, we should get an answer of -5. So we have -3 times 0 minus 5, -3 times 0 is 0, so we just get -5. And when we check, -5 is equal to -5, so this is part of our solution set. Then we check our last point. If this one works, f of 1 should be equal to -8. So -3 times 1 is -3, minus 5 is -8. So this one is also part of our solution set. And then sometimes we'll put them in brackets, sometimes we'll just list the points out, depends on how it's given to you. There's really no order here that we're going to follow because we've got two coordinates, so it doesn't matter the order that you write them in. We'll just find our solution set this way. For this one, we can't say that, when we solve it out, it should equal the y coordinate or it should equal the x coordinate, because both our variables are on one side. So for this one, we're going to substitute both the x and y coordinates in, and if it works, that means we'll get a value that's equal to 10. So for our first point, we have -1, -2. I just like to keep track of what I'm working with here. So we have 3 times -1 minus 5 times -2, and that should be equal to 10. So we have -3 plus 10. We can put little question marks up here because we don't know if they're equal. And so we end up with 7 not being equal to 10. So this point is not part of our solution set. Go ahead and pause the video, test out the other 3 points, and see if you can build your solution set. Alright, so after we test out each of those points, the only two that work for this function are 5, 1 and 0, -2. The next thing we're going to look at are composite functions. And when we see the word composite, kind of like the word compound, this means to put two things or more together. So this is where we're going to be combining different function rules together. Now, up until now we've seen everything defined as f of x, but if you look in my kind of word bank here, you'll see we have f of x, h of x, g of x, and k of x. To start us off, we just want to practice making sure we're good with evaluating functions for a given value. So go ahead and pause the video and see if you can do h of 5, k of -3, and g of -4. Alright, so for h of 5 we get 20, g of -4 we get 17, and k of -3 we get -9. Now for this one, our input's not just a number, it's the expression 2a. But our rule remains the same. Oop, we don't want to edit that. Sorry, we'll get right back into our full screen here. So my input now is 2a. That means that anywhere in rule h that I see an x, I'm going to take out x and put in 2a. So we have 4 times 2a, which is 8a. The 2a here is my input, just like the -4 was my input. The 5 was my input, and the -3 was my input. We're just taking whatever is inside those parentheses and substituting it in for x. Now for this next one, we want g of h of x and k of g of x. Whenever you see these, we always start with the inside first and work our way out. So we start with h of x. So we're going to take out h of x, and I see that my rule for h of x is 4x. So I replace h of x with 4x. Again, this is my input for function g. Now I'm going to take this 4x and use it into my function. So g is negative 3 times my input plus 5. Now my input is 4x, so we're going to substitute that in and then evaluate the expression. So we have negative 12x plus 5. Go ahead, pause the video, and see if you can figure out the second one, k of g of x. Alright, so k of g of x is on the inside in the middle, so that's where we're going to start, and that's my input to function k. If I look at function k, I'm going to take out x and replace it with the value of g, which is negative 3x plus 5. So we have negative 6 plus negative 3x plus 5, which leaves negative 3x minus 1. Okay, got a couple more we want to evaluate. So here we're going to find g of h of 2. Now instead of it just being g of h of x like we did before, we're going to start with h of 2. So again, I'm going to start in the middle. I'm going to say, okay, h of 2 equals 4 times 2, which is 8. So now I'm going to take this and replace h of 2 with 8. So g of h of 2 really is the same thing as g of 8. And if I'm finding g of 8, I'm going to go to rule g, take out my x, and plug in 8. So we have negative 3 times 8 plus 5, which is negative 24 plus 5, or negative 19. Go ahead and pause the video, see if you can find the second one. For this one, we should get an answer of 5. So we take the middle, g of negative 2, and evaluate that function. So negative 3 times negative 2 is 6, plus 5 is 11. Now we want to replace this g of negative 2 with 11. So k of 11 is negative 6 plus 11, which is 5. Sometimes we'll do it triple, and we'll do 3 or 4 functions nested all together. Again, the key here is to start on the inside. So we start with f of x. So my f of x is 2. So this is really going to be h of g of 2. We know the g of 2 can easily be evaluated. So we have not negative 2, positive 2. Negative 3 times 2 plus 5, which is 6 plus, or negative 6 plus 5, which is negative 1. And now we're going to take that g of 2 and replace it with negative 1. So now we have h of negative 1 equals 4 times negative 1, or negative 4. So altogether, h of g of f of x equals negative 4. It works the same if we have 4 functions nested all together as well. Go ahead, pause the video, and see if you can get this one on your own. Remember to start from the inside and work your way out. This one we start in the inside with f of x, which is 2. So g of 2, we know from the previous problem, is negative 1. So now we evaluate k for negative 1. So I take out the x, put in negative 1, we get negative 7. And then I evaluate h for negative 7, which leaves me negative 28. We can also put functions together using addition or subtraction. So here we have 2 separate compositions we're going to do. We're going to solve each of these individually and then put them together at the end to get the answer to our subtraction problem. So we start with k of negative 2, which is going to be negative 6 plus negative 2, which is negative 8. So now we need h of negative 8, which is 4 times negative 8, or negative 32. So that's our first piece. Then we do the second piece. H of 4 is 4 times 4, which is 16. And then g of 16 is negative 3 times 16 plus 5, or negative 48 plus 5, which is negative 43. Now when we go to subtract negative 32 minus negative 43, this becomes a plus sign. So we're going to end up with positive 11 as our answer. Go ahead and pause the video and see if you can do the second one on your own. For this one, we evaluate the numerator. We start with k of 12, which gives us 6. Then h of 6 is 24. Then we do our denominator. K of f of x is going to be k of 2, which turns into negative 4. And 24 over negative 4 gives us a final answer of negative 6. Ooh, that one went a little crazy there. We'll finish our circle. And that's the composition of functions.